This is example 7 from section 7.2, the final example from this section. And what we got is the integral of secant x over tangent of x squared. So, because we have secant and tangent stuff, it makes sense to start thinking about our trig integration, case B, which has to do with tangent and secants. Notice that we don't really have case I or double I applying to this because those have to do with secant being even and tangent being odd, neither of which apply. So we're in the other category, and it says, note you are given the integrals of secant and tangent. Could help to convert to sines and cosines, or use tangent squared equals secant squared minus 1. So, it's kind of a hodgepodge thing here. We just have to look at it and see what might apply and what might be helpful. The identity of the tangent squared equals 1 minus secant squared isn't really going to help us, because then we'll have minus in the denominator, and that doesn't really do a whole lot for us. Whenever you have a ratio of trig functions, it might be the case that things simplify if you put things in terms of sine and cosine. That's more familiar. So let's try doing that first. Alright, so secant can be represented as 1 over cosine, and tangent can be represented as sine over cosine, and because it's squared, we can represent that as sine squared over cosine squared. So we got some potential here for things to simplify. I'm going to write this out as 1 over cosine times cosine squared over sine squared, multiplying by the reciprocal here. And ooh, lucky day, we got a pair of cosines that are going to cancel there. So then what we'll have is cosine over sine squared. Now what? Well, there's actually two options that are equally good, and I'm going to do them both. So method 1 is picking up here and saying to yourself, well, maybe I can write this in terms of not sine and cosine, but maybe something like cosecant or whatever. And is that a basic integral that I know, or is on my formula sheet? So you do have some possibilities on your integration, or the integrals that are provided on exam 1 formula sheet. So if you look at those, you have some integrals here, like for cosecant times cotangent, for secant, etc., etc. So if you look at that, you might notice that, hey, I could write this integral in terms of one of the elementary integrals that's provided in the formula sheet. That being 1 over sine times cosine over sine. And if you have the order different, that's fine. But getting at the fact that what you have here is cosecant times cotangent. And that's on the formula sheet. So that's just given, and so it doesn't get easier than that. Definitely some insight to recognizing that, but from here on out we just write that result from the formula sheet and we're done. So that's one way. Another really good way, so I'll write method 2 here, is to pick up from what we have here. We're left off cosine of x over sine of x squared. And going back to basics here, maybe some sort of substitution would work. And what would that substitution be? So notice that we got a composite function down low. We got a sign that's nestled up with that squared, and the derivative sign is cosine. So this is a fairly straightforward substitution problem. We let our u equal sine x, and that implies that our du is equal to cosine x dx. So we can start identifying the parts. We got the u squared, which actually maybe I should rewrite this. I think we can just write it. So cosine x dx is our du. And then because our u is sine x, we got this over u squared. Alrighty, that looks great. Now let's just write this a little differently as u to the negative 2 du, which is an easy integral to take. We add 1 to the exponent, we get negative 1, bring that down low underneath, or actually it doesn't matter because it's just negative 1. So overall negative u to the negative 1, indefinite integral, so we just attach our plus c, and then let's write this as 1 over negative 1 over u, where u is sine x, just to kind of convince you that we get the same result here. Negative cosecant x plus c, so we got the same thing. And that's it.